All right, so let's pick up where we were. Domain, -6, 5, 9, and -2. What is our range in this? Our range is the y values. 0, 5, -2, and -9. So again, nothing repeats in the domain. Nothing in here is repeated. If it was repeated, it would not be a function. And we can see that by mapping everything. 6 goes to 0, 5 to 5, 9 to -2, and -2 to -9. Therefore, yes, that is a function. It's a function. Well, yes or no, we don't have to explain because it is a function. So, a couple of tables of values here. We're still going to have sets of numbers. What is our domain here? Our domain is these numbers on the left-hand side, the x's. X's are always our domain, right? So our domain is here. That's the domain. What is our range? Our range are these numbers over here. Do any of the numbers in that left column repeat? Yes, they do. We have a 1 and we have a 1. If we wrote this out as a set, which sometimes it's easier to see, right? Domain is equal to 1 comma 2. Now be aware you don't have to write, when you're writing the domain, that 1 twice, but watch what happens. Our range. Our range is equal to 5, 7, and 9. So where do we go? If we do this mapping, 1 goes to 5, 2 goes to 7, 1 goes to 9. That's what makes this not a function, this piece right here. 1 cannot go to two different places in the range. That means it is not a function. So I'll put a big red X through it, whatever you want. Number 4. What's our domain here? Domain, -12, -10, -8, -6. We can already see nothing repeats in there. What's our range? 0, 1, 2, 4. Right, and if we draw a little arrow diagram, -12 goes to 0. I'm going to try something here. Don't know if it's going to work, but I'm going to give it a shot because I bought this little pad thing. So let's see if that works for me. Right, so we have that, right? And then -10 goes to 1, -8 goes to 2, and -6 goes to 4. So if we have that, then we know we have a function. So yes, this is a function. Well, writing's a little better like this. I got to get used to this little pen thing I got. All right. Here we've got, this is called a arrow diagram. But if we look over here, let's see, I want a different color. So let me go to blue, right? So if we go over here, we start at this 3, it goes to 2. -1 goes to 2. That's okay. Two things in the domain can go to one thing in the range. Here and here. Well, looks like we have a function. Yes. Because these things don't repeat. What's our domain? Our domain is equal to 3, -1, 0, and -2. What's our range? Our range is equal to 2, negative 3, negative 2. Yeah, it's a little crooked, but I got to try to figure out how to write straight on this. All right, so we're good. Correct? Because here, whoops, there we go. 3 goes where? 3 goes to 2. Negative 1 goes to 2, but that's allowed. 2 things here can go to 1 thing here. 0 goes to negative 3, and negative 2 to negative 2. Great. So what do we have in this second one? Well, in this second one here, let's take a look. What's our domain? Whoa, that's weird. Whoa. Okay, there we go. Negative 4, negative 7, negative 8. Now we can't tell immediately just by looking at that whether it's a function or not because we have this list of numbers, but our range is equal to 2, 3, 5, and 6. So what happens? Where are we? Got one red. No, there we go. Right? Negative 4 goes where? Negative 4 goes to 2. But negative 4 also goes to 3. Immediately, as soon as this happens here, not a function. Not a function because the x's cannot repeat. As soon as it goes to 2 pieces of the range, not a function. All right, here we had an interesting problem. You kind of had to figure out the domain here. It didn't give you anything. So how do we know the domain? Well, we got a coordinate plane here. So we're going to have to look at each of those points. Do any of the x's repeat? Well, kind of hard to tell right now, but let's take a look. And they're blue dots. So what would this point here be? That's negative 1, negative 3. So I have negative 1, negative 3. And this point, 0, negative 2. 0, negative 2. So far, so good. This point, 1, negative 1. 1, negative 1. And then this point up here, 1, 2. Uh-oh. As soon as we have that, as soon as you see this, let me get up there. As soon as we have this here, the ones repeat, not a function. And we're going to talk about another way to tell whether this is a function or not. There's a thing called the vertical line test. A vertical line is a line that goes up and down. If I can draw a vertical line through the graph, let's make it red, right? Let's see if I can get that. So if I can draw a vertical line through the graph and it touches, if it touches the graph in 2 different points, where am I touching here? I'm touching here and I'm touching here. If it touches 2 points, immediately know we do not have a function. So when you're given a graph, you don't have to always write out all of these pieces here, right? Don't have to write all this out. We can do the vertical line test. So let's look at that at number 8. Can I draw a vertical line that touches more than one of these points? Well, I don't know. Let's try it, Mr. Castro. Okay, let's do that. And here, I like purple. All right, so I have a vertical line here. How many points is that touching? Just one of them. Another vertical line here. Touches 1 point. Touches 1 point. Oh, look at that, 1 point. And 1 point. Have to move that over a little, but that's okay. 1. Yep. And, oh, that's really way over. Let me see if I can move that over. There we go. So as soon as we have a situation like this, we don't have to write out all of these ordered pairs just to see. This passes by the vertical line test, VLT, vertical line test. All right, that's a nice little tool to have. Should have told us about that earlier, right? Right. All right, so let's take a look at the next slide. Whoop, there we go. All right, state the domain and range of each relation, then determine whether it is a function. I like my blue. So what's our domain here? Domain is equal to which set? -6, -5, -3, -1, 6. As soon as I see that, nothing repeated. None of these numbers repeated. So I know I have a function. All right, just says to state the range as well. So we're going to state the range. It's the set of -1, -9, -7, 7. And look, I have -9 already in my list. I do not have to write it again. And if you look at this, because none of these repeat, nothing repeats here, that makes this a function. All right. Ooh, we got graphs. What can we use here? We can use the vertical line test. So let's get a vertical line. I don't know, what color should I use? Let's use orange for October and Halloween. Right? So, what do we got? All right, I'm not perfect on these, but uh-oh, what just happened there? Did that line touch two dots? Yes, it did. Therefore, whoops, this is not a function because of this and this. Not a function. Fails the vertical line test. Let's take a look over here at this one, this arrow diagram, right? All right, our domain, that's good. -2 goes to 2, -1 goes to 6. We're good still. 0 to 4 and 1 to 6. Wow, okay. Nothing leaves here twice. So yes, this is a function because the elements of the domain do not repeat. We're on fire now. All right. Couple more examples and questions. Problems. Again, looking right here. Are we good in this one? Leaves, leaves, leaves. Don't leave twice. As long as it doesn't leave twice, yes, it's a function. It says to state the domain and range. So I'd want you to, if it ever says that, to write the domain. The domain is those left values. 5, 6, -2. And our range is equal to 3, 1, -8. And you can see that, yes, this is a function. How about here? Well, right away we see this is going to fail that vertical line test. Hits it in these 2 points, so it's not a function. Even though it's set to write the domain, it's okay if you don't. When I test you, quiz you on this, just tell me if it is. Here we can see immediately, nothing repeats over here. Nothing at all repeats. If it doesn't repeat, it is a function. And again, a couple of things here. Well, let's take a look closely at this. It says to state the domain and range. I'm not going to right now because as soon as I see right here these two values, what do we know? As soon as we see those two things, we know it's not a function because values in the domain, the x's cannot repeat. And this one over here, well, since that's in red, I'll go to blue. Well, 2 to 6 is good, 4 to 14 is good. However, right here, -8 goes to 2 different places, therefore not a function either. And if we look at this one, we got -3, -1, 3, and 5. None of the domain repeats. Therefore, yes, this is a function. I think that was the last one. I'm pretty sure it was. Hold on 1 second. And let me go here.